Hello folks, we are once again back with our integration, but now the exercise has changed. We are going to the exercise 7.3, which is basically an exercise on a trigonometric problem. So you are going to have trigonometric functions coming up there. We have to use several trigonometric formulae, try to simplify the function and then do the integration. So that's our work going to be our work. Whatever we have studied in the 11th standard, we will be taking those formulae. We'll be simplifying the functions and then we'll be applying our integration. Now before we start with that integration, there are some more formulae that we need to learn. As I told you, we will always add to the database of the integral formula that we already have. So to that we are going to add these formulae. Integral of tan dx is log modulus sec x plus c. That's the integral of tan dx. Then integral of cot x is going to be log modulus sin x plus c. Integral of sec x is going to be log modulus sec x plus tan x plus c. Integral of cosec x is log modulus cosec x minus cot x plus c. That's it. So it is to be adding to whatever we already have. And now let's continue with the exercise 7.3. The very first question is I equal to sine squared 2x plus 5 dx. Now the problem is we have not learned an integral formula that has got sine squared. So obviously here we are going to use some formula that will make it in terms of cos or sine, because we know that we know integration for cos and sine, but we don't know the integration for sine squared. So we'll apply some double angle or triple angle formula and try to bring it in terms of sine and cos so that we're able to work further. So for this, the formula that we're going to use is, we know from the 11th standard portion that sine squared theta is 1 minus cos 2 theta over 2. So we are going to use that formula. And I therefore, by using this formula, is going to be 1 minus cos 2 theta. So it's 2 times 2x plus 5 whole over 2 dx. So when we write it, it's like this. It is half times dx, first part, and second part is half times cos, if you could open this, 4x plus 10 dx. That's it. So the catch of the problem is to apply this correctly. So then it's easy. We have integration of dx, we know is x, and we know that cos 4x plus 10. The integral formula is sine 4x plus 10, but because there is this constant of integration 4, that also you need to put there plus c. If you want, when you simplify, it can become x over 2 minus sine of 4x plus 10 over 8 plus. That's all. So it's just a matter of getting the right conversion so that you are able to do the integration easily. So that's our first question. Let's go to the second one. In the second one, it says that it is sine 3x times cos 4x. So I is sine 3x times cos 4x. Now the same thing is going to happen here. Products we have not studied till now. We have only studied single sine and single cos and things like that. So because you don't know the product, there's no problem, because we have studied the product formula last year when we were doing the trigonometric function. Let's use the product formula. So in the product formula, we had sine A cos B, or maybe cos A cos B, sin A sin B. Whenever we have sin A cos B, it is going to be sine of a certain function. Both are going to be sines depending on the values of A and B. So we are going to check whether sine value and cos value, how they are. The sine value is smaller, cos value is bigger. That means there is going to be a subtraction in between the two formulae. That's how we learned it last year. So therefore this is actually by that formula. So I will just let you know how the formula is. If your formula is sin A cos B, where obviously we are treating A as bigger, A as smaller. If that is the case, then your formula is sin A plus B minus sin A minus B, and this whole thing is over 2. So that's how it is. So it is going to be, so when we write this, we try to use this formula. It is going to be sin A plus B. That means sin 3x plus 4x minus sin Okay, so let's put it as plus because that minus will be taken care of by that a minus b. So it's 3x minus 4x. Let's put it plus. Okay, over 2 dx. So half you can take out of the bracket, and inside we have sine 7x plus sine minus x dx. Now we know sine of minus theta is minus sine theta. So when we write it, it's going to be half integral of sorry, sine 7x dx minus, the minus is moving out, integral of sine x dx. That when we further simplify, it's the sine integral we know is minus cos. So it's going to be minus cos 7x, integral coefficient 7, and plus cos, because minus and minus, and here no integral coefficient, plus c. So if you want, when you expand it, it will be minus cos 7x over 14 plus cos x over 2 plus c. That's for it. So that's your integral. Yeah, minus cos 7x over 14 minus cos, yeah, right. Okay, before we move to the next question, yeah, that's going to be, next question is going to be the third question. So let's quickly see what the third question is going to be like. Yeah, let me just go through the question and see what does it say. Cos 2x, cos 4x, cos 3x. We are going a step ahead where we are getting a product of three terms. It is cos 2x, cos 4x, cos 6x dx. I'll once again check the question if it's correct. Cos 2x, cos 4x, cos 6x. So we got a flavor of the product from here where we had only two terms. Now we are having three terms. Actually what we are going to do is we are going to repeat this procedure twice, thrice in order to get the integral. So what I would suggest is, instead of working in the integration all the time, putting the integration sign and writing that term like that, let's just take the function separately, work it out, bring it in our desired form, and then go for the integral. So that will be better. So let's consider that. So let's consider that function. Consider cos 2x, cos 4x, cos 6x. Let's consider this and let's see how we can move it. So as we do it, let's take the product cos A times cos B. So I'll quickly give you the formula. The formula says like this, that cos A cos B, if you have, then your formula is half times cos A plus B plus cos A minus B. So let's quickly apply the formula. So it's going to be half times cos 2x, cos 4x we are considering. So you're going to get half times cos, sum of it, 2x plus 4x, 2x plus 4x plus cos 4x minus 2x or 2x minus 4x. In cos it does not matter because cos of minus theta is cos theta. So it doesn't matter. You write it anyway. In sine you have to be careful, but cos it doesn't matter. So this comes to cos 6x plus cos 2x when you simplify. So you have got cos 6x plus cos 2x over 2. So when we again bring this back, so yeah, so what is it? All the time there is a cos 6x outside. Okay, please don't forget cos 6x is there outside. Cos 6x is there outside. So cos, let me write it properly because it will be confusing. Cos 6x over 2, because you have only simplified the remaining part. Now let's open the bracket. So when you open the bracket, you are getting cos squared 6x over 2 plus cos 6x cos 2x over 2. Again we have to apply the formula, that's it. Now what formula are you going to apply? For cos squared theta, as we did for sin squared theta, there is a formula which says that it is 1 plus cos 2 theta over 2. In order to remove the square, we are not happy with the square because we don't know the integral of the square. So in order to remove the square, we are going to use that formula. So also for the product, you already know this formula, cos A times cos B. So let's apply that and let's see now how this is going to come. So for the first part, half is already there. And now when you apply this formula, it is going to be 1 plus cos 2 times 6x over 2. So that's the first part. Second part, half is already there. Again half will come because of the formula, and it is cos 6x plus 2x plus cos 6x minus 2x. So when we apply this, it is going to come to 1 over 4 when we open the bracket. First term. Second term, cos 12x over 4. Next term, here this one, this is cos 8x. So cos 8x over 4. Then this is cos 4x over 4. Okay, we've got it simplified. So it is for us to now get the integral. So now let's check how are we going to get the integral of this. So let's quickly go in to find the integral values. So therefore I is now becoming integral of all those. That is 1 over 4 plus cos 12x over 4 plus cos 8x over 4 plus cos 4x over 4 dx. So integral of each of them. So 1 over 4 dx, then maybe this 1 over 4, why can't we take it out? Yeah? So 1 over 4 cos 12x dx, then 1 over 4 cos 8x dx, then 1 over 4 cos 4x dx. So quickly let's try to see what the integral is all about and see how it comes. Yeah, so this is going to be 1 over 4 times x. Integral of dx we all know is x. So also 12x, we know the integral is sine 12x. 4 is already there and 12 is the integral coefficient. Then sine 8x for cos 8x, the integral is that. 4 is already there, let's get the 8 as because it's the integral coefficient. Now this is sine 4x. 4 is already there, 4 is coming plus c. So let's write this. This is x over 4. This is sine 12x over 48. Then sine 8x over 32. Sine 4x over 16 plus c. That's all. So that should be all for this video, where we have done 3 good problems where we have used our 11th standard logic and we have tried to simplify the function, get the integral. That should be all for this video. With more problems, let's meet in the next video. Thank you.